Hey guys, this is Gradius, and this is the video for stretching and shrinking absolute value graphs. So this is another part two of a couple videos. So if you've not learned how to translate absolute value graphs, please go back and watch that video first because we're going to be doing that in here already. So make sure that you know how to translate graphs left and right, up and down before you watch this video. So real quick, we know that absolute value graphs, we normally put them in HK form. An HK form looks something like this. We just want to go over again what HK form actually is, what each piece means. Okay, we know that this H is the horizontal shift, so this is what shifts the graph left and right. Okay, this is H right here. The K is what determines whether the graph goes up or down. And then this A right here, this is what we're going to be working with today. This is what determines whether the graph stretches or shrinks at all. And what really the way it does that is this is the slope. So this is the slope of my absolute value lines. Okay, and we're going to look at that and see exactly what that means in just a second. But just a quick little reminder from a previous video. Negative HK. So this HK, this is your vertex. This is the starting point of the graph. Okay, so we always take whatever H is here, negate it, so take the opposite sign of it. So if this is x minus 3, then that means our x coordinate is going to be positive 3. And this was 2. Then our y coordinate is 2. This is my vertex of that graph, and this is where I start, and this is where I use my slope from there. So just a quick little refresher, but let's take a look at some equations. So first, I want to graph the function y equals 2 times the absolute value of x. So the first thing I do is I start with my vertex, and then I use my slope from there. Well, if we look, this is just kind of like the parent function where there is no horizontal shift because it's just absolute value of x. There's nothing else inside of these parentheses. So my x coordinate, my vertex, my x coordinate is going to be 0 because there is nothing inside of here. And then there's nothing on the outside. It's like having a plus 0 right here. So that means my vertex is the origin. It's 0, 0. So that's where I'm going to start. Now that I figured out what my vertex is, now I can look at what my slope is. Because I'm multiplying the absolute value of x times 2, that means that this line has a slope of 2. So just like before when we graphed the linear equations, okay, now we're graphing absolute value equations with a slope of 2 over 1. So now I'm just going to go up 2 over 1. Before, with the parent function, we went up 1 over 1, up 1 over 1. Now, this graph just got a little bit skinnier by going up 2 over 1. And then, but because it's an absolute value graph, we know we have a V shape, so we need to go up 2 over 1 to the left as well for all of my negative values. And that's it. So what happened is this just became a little bit skinnier than it was before. Because if I had graphed, let me do this in a different color just to show you. If I did y equals just the absolute value of x without that 2 in front, I would start at 0, 0, but then I'd go up 1 over 1. And see it'd be a little bit fatter. Now it would be this graph right here. So what we did by having a slope of 2, we made our graph just a little bit skinnier. Okay, so let's look at another problem. So now I have y equals 1/2 times the absolute value of x. So again, I find my vertex first, and if we notice there is no horizontal shift in here, okay, there is no vertical shift out here, so I'm going to start at 0, 0. I start at the origin. And then now my slope is 1 over 2. So instead of going up 2 over 1 or up 1 over 1, I'm just going to go up 1 over 2. Rise over run. Up 1 over 2. Up 1. And so it should look something like that. Now, because it's an absolute value graph, I need to make that V shape, so I need to go the other way. So I need to go up 1 and to the left 2. Up 1 and to the left 2. Up 1 and to the left 2. And so by having a slope of 1/2, what I did is my v just became a lot fatter. Because again, if I were to graph the parent function, y equals the absolute value of x, we would start at the origin, but then we'd go up 1 over 1, and it'd be a little bit skinnier. Not perfect lines, but they work. Okay, so this would be the two graphs for y equals 1/2 times the absolute value of x, and then y equals the absolute value of x. So when we have 1/2 as our slope, our v became a little bit fatter. Let's look at a couple more practice problems, and then we're going to be done. We're going to learn one more thing as well. So y equals 3 times the absolute value of x plus 2 minus 3. So for this one right here, I'm actually going to move this around a little bit because we might need that space. So I need to figure out what my vertex is first. Well, it looks like, because if we remember, the vertex is negative hk. Here's my h. Here's my k. So I need to take the opposite of whatever's inside of here. So because this is positive 2, my h is really going to be negative 2. And then my k is just negative 3. So my starting point for this graph is negative 2, negative 3. So let's start that point first. There we go. There's where there's the vertex and where this graph starts. So now what I need to do is I need to graph my slope. Well, my slope is 3, or also just 3 over 1. So that means my rise is 3, my run is 1. So from my vertex, I'm going to go up 3, 1, 2, 3, over 1. 1, 2, 3, over 1. I think 2 points will be enough. 1, 2, 3, and I need to do it the other way. So I need to do it going positive slope, negative slope, and that's going to give me my v. And there's my graph for this function. So now what we want to look at, is what happens if my slope is negative. If I have a negative slope on the outside of the absolute value graph, then what happens is my v actually flips upside down. It reflects about the y-axis. So it just flips over. So instead of going up like so, it's now going to go downward. Okay, so let's go ahead and see what that looks like with a couple of examples, and then we'll be done with this video. So I have the function of x is equal to the negative 2 times the absolute value of x plus 2. So, no, excuse me. No, excuse me, sorry. So what I need to do is I need to start from my vertex. Well, I notice it doesn't shift left and right. There is no horizontal shift here. So my x-coordinate is going to be 0. But my y-coordinate is 2. So this graph's going to shift up 2. So here's my starting point. Let's do this in a different color. Do it in blue. So there's my vertex of this graph. Now I have a negative 2 slope. So what I'm going to do is, instead of going up 2 over 1, up 2 over 1, I'm just going to go down 2 over 1 to the right, down 2 over 1 to the right, and I'm going to go back to my vertex, and then go down 2 over 1 to the left, down 2 over 1 to the left. And that would be the graph of this function. Now my v is going downwards, facing downwards, because I have a negative slope. Let's look at one more and then we'll be done. This one in orange. So first thing I need to do is find my vertex, negative hk. So because it's negative 2 on the inside, that means my vertex is going to have an x-coordinate of positive 2, and then negative 1 based on these two values right here. So we'll go positive 2, negative 1. There's where my graph, there's the starting point of my graph. There's my vertex. Now I get to graph my slope, negative 1/3. So because it's a negative slope, instead of going up, I'm just going to go down. So I'm going to go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. I need to go back to my vertex and do it going the opposite direction. Down 1, go over 1, 2, 3. Down 1 over 1, 2, 3. And then there's my v. This is definitely a fat v because the slope is 1/3. And I'm done. Okay, so that's it. So just a quick little recap. First thing we do when we graph absolute value functions is we always figure out what our vertex is, and then we start. And remember, our vertex is always just a negative hk. Here's my h, here's my k. So I always take the opposite of what h is, and I take whatever the k is, and that becomes my x and y coordinate. Then from there is where I use my slope. Okay, and my slope is always a number that's outside the absolute value symbols. And if it's a positive slope, then my v is going upwards. And if it's a negative slope, then I flip over my v, my graph, and it's now facing downwards. And that's it. So hopefully this video helped, and good luck, you guys. Thanks for listening.